We continue with the revision of atoms and molecules. Writing chemical formulae of various compounds. For writing the chemical formulae of different compounds, we should know the symbols and valencies of the constituent elements. The combining power or capacity of an element is known as its valency. Another rule for writing the chemical formulae is, in case of a compound composed of a metal and a non-metal, we should remember to write the symbol of the metal first, followed by the symbol of the non-metal. This is an important table which should be memorized because it lists various ions along with their valencies, and it also tells us whether it's a cation or an anion. Cation is a positively charged ion and anion is a negatively charged ion. So in the first column, we see all the ions are positively charged ions, and remember all of them are the metals. So sodium, potassium, silver and copper, all of them, they have +1 valency, whereas magnesium, calcium, zinc, iron and copper, they have 2+ valency, and aluminium and iron, they have 3+ valency. Here you should note that copper and iron, they exhibit 2 valencies. Copper, it can be either 1+ or 2+. In case of iron, it can be either 2+ or 3+. Here, the second table, it lists various nonmetals. Hydrogen can exhibit 1+ or 1- valency. So, if the valency is 1+, then it is called as hydrogen. If valency is 1-, it is called as hydride. Chlorine, bromine and iodine, they exhibit valency of 1-, and they are called as chloride, bromide and iodide. Oxygen and sulfur, they exhibit valency of 2-, they are called as oxide and sulfide, whereas nitrogen exhibits 3- valency and it called as nitride. The polyatomic ions, the third column has the polyatomic ions. Ammonium is NH4+, hydroxide is OH-, nitrate is NO3-, hydrogen carbonate is HCO3-, carbonate is CO3 2-, sulfite is SO3 2-, sulfate is SO4 2-, and phosphate is PO4 3-. This table should be memorized so that we can write the correct chemical formulae of various chemical compounds. Some of the examples here. So the first compound under consideration is hydrogen sulfide. The constituent elements are hydrogen and sulfur. You should write down the chemical symbols or symbols of those elements, and right below the symbols you should write the valencies. Then you should have this cross multiplication, so this 2 gets attached with H and this 1 gets attached with S, thereby giving us chemical formula H2S. Next compound under consideration is aluminium oxide. Symbols of aluminium and oxygen are Al and O. Their respective valencies are 3+ and O2- or 2-. Therefore, the chemical formula becomes Al2O3. The next examples are magnesium. You can see here, the next example has magnesium hydroxide, where the chemical symbols are Mg and OH. So the chemical formula becomes MgOH twice. Calcium oxide, the elements involved are calcium and oxygen. The symbols are Ca and O. The valencies are 2 plus and 2 minus. So does it mean that the formula becomes Ca2O2? No. In such cases, we find out the HCF of both the values, both the valencies, and divide those numbers by the HCF. So the chemical formula of calcium oxide is CaO. Similarly, carbon dioxide, the constituent elements are carbon and oxygen. The respective valencies are 4 and 2. So the chemical formula, so HCF of 4 and 2 is 2. We divide both 4 and 2 by 2. Therefore, we get chemical formula of carbon dioxide as CO2. Now we discuss molecular and formula unit mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. For example, if we find out molecular mass of C2H4, then molecular mass of C2H4 is number of carbon atoms multiplied by mass of one carbon atom plus number of hydrogen atoms plus mass multiplied by mass of one hydrogen atom. Thereby, we get molecular mass of C2H4 as 28 U. Formula unit mass of a substance is a sum of the atomic masses of all atoms in a formula unit of an ionic compound. So the example is to find the formula unit mass of K2CO3. Therefore, the formula unit mass of K2CO3 will be mass of potassium plus mass of carbonate. And if we calculate the values by substituting respective masses, we get formula unit mass of K2CO3 or potassium carbonate as 138 U.